Imagine a highway during rush hour. Cars, trucks and motorcycles zoom around at high speed. Now picture this highway littered with debris. Old tires, broken down vehicles and pieces of metal flying in every direction. That's a glimpse into the current state of Earth's orbit, where a growing cloud of space debris poses a serious threat to satellites and future space missions. This debris, ranging in size from tiny paint flecks to defunct satellites, circles the Earth at incredible speeds, reaching up to 17,500 miles per hour. At such velocities, even a small piece of debris can cause significant damage upon impact. As we continue to launch more objects into space, the risk of collisions increases, endangering our access to vital services like communication, navigation, and Earth observation. The European Space Agency, or ESA, has been closely monitoring this issue, and their reports paint a concerning picture. The ESA warns that the amount of space debris is reaching a critical point, with over 34,000 objects larger than 10 centimeters in diameter currently being tracked. These larger objects are just the tip of the iceberg. Millions of smaller debris pieces remain undetected, posing an even greater threat due to their sheer number and unpredictable trajectories. ESA's findings highlight the urgent need for action to address this growing problem and protect our space infrastructure. The sheer scale of the space debris problem is staggering. Over 130 million objects smaller than 1 centimeter are estimated to be in Earth's orbit. These tiny fragments, traveling at incredibly high speeds, can cause significant damage to operational satellites, even puncturing vital components or disabling entire systems. The larger pieces, ranging from a few centimeters to several meters in size, pose an even greater threat. Collisions with these objects can be catastrophic, potentially destroying satellites and creating thousands of new pieces of debris in the process. As the amount of space debris increases, so does the probability of collisions. This leads to a dangerous chain reaction known as the Kessler syndrome. In this scenario, a single collision creates a cascade of subsequent collisions, generating more and more debris and exponentially increasing the risk to spacecraft. This runaway effect could eventually render certain orbits unusable, effectively cutting off our access to space. The Kessler syndrome is a stark reminder of the interconnectedness of objects in orbit and the potential consequences of inaction. Section 5. Clear Space 1. Taking out the trash in space. Recognizing the urgency of the situation, ESA is taking concrete steps to address the space debris problem. One such initiative is the Clear Space 1 mission, scheduled for launch in 2026. This groundbreaking mission will be the world's first to remove a piece of space debris from orbit. Clear Space 1 will target a Vespa payload adapter left in orbit after a 2013 launch. The mission will demonstrate technologies for rendezvous, capture, and deorbiting debris, paving the way for future cleanup efforts. This pioneering mission marks a crucial step towards mitigating the threat of space debris and ensuring the sustainability of space activities. The space debris problem stems from various sources. One major contributor is defunct satellites. As satellites reach the end of their operational life, they often remain in orbit, posing a collision hazard. Another significant source is spent rocket stages. These large structures, used to launch payloads into space, often remain in orbit long after their mission is complete. Additionally, accidental explosions and collisions in space have contributed to the growing cloud of debris. To combat the space debris problem, scientists and engineers are developing innovative technologies for debris removal and mitigation. One promising avenue is laser tracking systems. These systems can precisely track debris objects, improving our understanding of their trajectories and enabling more effective collision avoidance maneuvers. Another area of development is robotic capture technologies. These robots would be designed to grapple and deorbit debris objects, either by slowing them down so they burn up in the atmosphere or by redirecting them to a graveyard orbit. Addressing the space debris problem is not just the responsibility of space agencies, it requires a global effort. International cooperation is crucial for developing and implementing effective debris mitigation guidelines and regulations. Satellite operators must also play their part by adopting responsible end-of-life disposal practices, such as deorbiting satellites or moving them to graveyard orbits. By working together, we can ensure a sustainable future for space exploration and protect this invaluable resource for generations to come. The growing threat of space debris demands our immediate attention. Our reliance on space-based technology is only going to increase, making it more critical than ever to protect our orbital environment. By investing in innovative technologies, fostering international cooperation, and promoting responsible space practices, we can clean up our act in space and ensure a safe and sustainable future for all. Let us remember that space is not a limitless resource. We have a collective responsibility to preserve it for future generations. The time for action is now. Let's work together to keep our celestial backyard clean and safe.